For example, if I take this one, then I can count the number of 1 in zeros in this. For example, if I take this one, then I can count the number of but I mean this is the standard type. It is not a problem. We can follow the approach. But do we need to, each time calculate the number of zero and ones? So if I did that, but it was wrong. So we contain the current string, but we can only take this one if satisfy this condition. It means the number of zero contained will exist in this current string or the current element of the array, are lesser than or equal to for the number of 0 and 1s left in this position. That's why we are let's say okay. So number of 0 and 1s we already know. Then we are calling this function for f of 0 and right m1. So this position is 5 and this is 3. N is equal to 5, N is equal to 3. Now when we are at this position of I0, can we take this? Can we include the current element in the final answer? What is the final answer? The largest subset. We can only include this if the number of 1 in zeros are less than or equal to the 1 we are allowed to have. So at x0 we are allowed to have 5 and 3. So we can take it. That's why we are having this condition. Then I will add 1 to it. Okay. So at this position we have this and this one. Okay. Let's first call this one. Call this is equal to f of I plus 1. So that will be 1 and we will not change m and n. That will still stay the same. Now at this position we will take the current one. So that will be this one. We are including this in the final subset that we are returning as our answer. 1 plus, then we will go to the next one, I plus 1, so that will be 1, and the number of m and n that are left will be the ones which we already had minus these ones. So 1 minus 0, 1 1, yeah, both are 1 1. So we will call this 4 and 2. Right? M is 1 and N is okay. M is 0 actually. Zeros and N is 1s. So it's clear for us now. So we have called this one. Now we are calling the same function, this one, right? F of, now if we are not taking, then what we will do? We will go to the f of 2, f of 3 without, if we don't change these things, if we don't take these elements, then we will go to the next element without changing the number of 1 in zeros left. So we can say 2, still 5 and 3, okay, and again f of 3 still 5 and 3, then f of 4, 5 of 3, and the length, we have to say the length of this is 0, 1, 2, 3, 4. N is 4, N is 5, and okay, now we are at this position. I is 4, I'm this position I is 4, so now I will decide to not take this one and go to the next one. If I go to f of 5 and 5 and 3 means I have this string array is exhausted. It means I cannot create further subset because the array is empty. So that's why I will return 0 from here. This will return 0. So this will return 0. Now this will also return for this one. This part, if 4 and 5 and 3, we are at this position, right? At index 4 mean at the last element. So first time we skip this one, now we will take this one. Can we take this one? Yes, because the number of zeros and ones we can have is 5 and 3. So in this position the number of 0 is 1 and the number of ones are 0. That's why I can take this one. I will add so this was the skipping part, right? The skipping part will return 0 and the taking part will be 1 plus f of 5, and we will decrease the number of zeros because we are counting 1 from the current element. There will be 4 and the next one will stay the same because we don't have 1 here. So at this position we are already exhausted the string. So I will return 0 for this. This will return 0 and this will be 1. So this will be 1 and the list is the maximum. So that's why this will return answer will be 1 for the f of 4, 5, 3. Now at this index 3, 0, 1, 2, 3 at this position, first we went through this branch, right? On this branch, which is f of 4, 5 and 3, we didn't take this one. And the answer we got from this was 1. Now if we take this one, the answer from this was 1, right? And if we take this one at index 3, then I will add 1 to the f of 4. At this time I will decrease 1 from the ones and zeros will stay the same, so it will be 5 and 2. Now at this position f of 4, 5 and 2 do we have? No. Now we will calculate this one. F of here f of 4, 5 and 2. Okay, so now I'm in this position. I can now again take it or not take it. If I take it, if I don't take it, then I will simply go to the next one. F of 5, that will return 0. If I take this one, so I will say 1. Then again I will go to f of 5, right? F of 5 will again return 0. That's why the best answer is f of 1, right? F of 1. So the answer for this is 1. So this will return 1. This will return 1. We will add 1 to it. So the answer is 2. At this position we will return 2. The answer is 2. So at index 2 we can follow the same approach as the same thing. If I take this one, then I will fix. If I skip this one, then it will be f of 3, 5 and 3, 5 and 3. The answer we got this was 2. But if I take this one, it was at this position. If I don't take this one, so the answer was 2. If I take this one, so the answer will be f of again 3, but the number of points are 4, and we have the number of ones as 3. So it means I cannot have this one as my answer, as a part of my as a part of my subset, because the number of ones exist in this element is more than the one I am allowed to have. So the number of ones are 4 here, but I am only allowed to have 3. So that's why I cannot call this branch, right? I will simply skip this one and I will return, the answer will be 2. So this position, for the best answer we can get from this code is 2, right? Even if we observe, that's correct, because 1 in 2 we can take, because the number of 1 and 0 are lesser than or equal to this, so that's correct. Right? It's satisfying this given condition. this at most m zeros and n ones, but then this is correct. Now we are at index 1, right, this position. So we didn't take this one, we went there. If we take this one, left to right like this, we went there without taking the current one. The answer we got was 2, right? But if we take this one, then we will do f of 2, again we will go there, but we will, decrease the number of zeros and one included in this position. So it will be 5 minus 3 will be 2, and 3 minus 1 it will be 2. So now we are at now we are going to this position, right? Now we will call f of 2, 2, 2. Now again same for this position, we can we take this one? First we will skip this one, we will go to f of 3 of 2 into 2. But if we take this one, can we take this as a part of our subsequent subset? No, we cannot take this one because only the number of ones and zeros are related with the one we are allowed to have. So we will simply skip this one. But if we don't take this one, we will come to this part. Now, at this position, 3, this, getting really messy, but on this position 3, 2, 2, okay, means we are on this position. If I skip, then I will go to f of 4, 2, 2, f of 4, 2, 2. If I skip this one, I will go to f of 5, that will return 0. If I take this one, then it will be 1 plus, I will go to the next, that will be f of 1, and I will decrease the number of zeros, right? Ones will stay the same, I will only decrease the number of zeros, so it will be 1 and 2. Now we have exhausted the string, so this will return 0. The answer will be, for this part, the answer will be the maximum is 1. So this will return 1 for this part. Now we are in index 3, we didn't take this one, we got the answer 1, so we will take the current element, that's 1. So we will call f of still 4, we'll go to the next, but if we take this one, we will decrease the number of ones, that will be, the zeros will stay the same, it will be 1. Okay, Now we will create another branch for this for 4, 2 and 1. Now this position, get this position, we will skip this one. If we skip it, we will go to f of 5, that will return 0. If we take this one, then we will call f of 5, but for lesser zeros, right? That will be 1 and 1, and we will add 1 to it. So the maximum we can get from here is 1. The answer is 1. We will get from this 1, we will add 1 to it. The answer is 2. For this we got, for the skipping code we got 2. But if we take this one, we are this position, and we take this one, the number of zeros and ones allowed are 2, but only at this element we have 4 ones, so we cannot take this element as a part of our subset. So we will simply skip this branch and we will return our answer. This position, our answer will be 2. Now we were at 1 at this position, right? We were here. When we skip, we got the answer as 2. But if we take this one, we will add 1 to the result return from this one. We got the result was 2. So we will add 2 to this one, and the answer is 3. So the answer is equal to 3. So 1 plus 3 will return 3. Now we were at index this position in the first one. For this part, F153, we got the answer as 3. But if we take this current element, then what will happen? We will add 1 to the 1, 4, 2, because if we take this one, we will decrease the number of ones and zeros from the one we are allowed to have at this position to 5 minus 1 and 3 minus 1. Now we will call this one. Yep. So at index 1, we can skip this one. Skip. We can do something like f of 2, 4 and 2. Yep. But if we take this part, then it will still be f of 2, but the number of zeros will decrease by 3. It will become 1. The number of ones will decrease by 1. It will be 1. Now, even for this same part, 2, 4, 2, do we have calculated this one? 2, 4, 2, we don't have this one. So we had already calculated this one, so we will return this from the normalization. Otherwise, we will call this F242. Okay. Now we are at this position. We are allowed to have 4 0 and 2 ones. This position, first we will skip this part, the part of this branch. Then we will take it as a part of this branch. So I skip it, then I will go to the next element, that will be 3, without changing the number of 0 and 1s we can have. But if we take this one, so it will be, we are at 2, right? We cannot take this spot because the number of 0 and 1s are more. So we cannot take this and we will just follow this branch. We are at this position of 3, 4, 2. Do we have already this? 3, 4, 2. We don't have this. Then we have to calculate this. At this position, I will first skip the current element. I will go to f of 4 without changing the 0 and 1s. Now I will take this one because I can take this one, right? The number of allowed are 2 and 4. I have only 1 here, so I will say f of 4 decrease the number of 1. 0s will stay the same. It will be 1. Now I will follow this same as branch. Now I am at this position. If I skip this one, I will go to the f of 5 without changing 4 and 2. This will return this is 0 because we have exhausted the string. Now I will, if I take this one, can I take? Yes, because number of 0 allowed are 4. I will add 1 to the f of 5. 3 into this will return 0 because it's equal to n. This will be 1. The answer for this is 1. Now we got the answer for this as a 1. For 1, do we have the answer for this one? 4, 4, 1. No, we don't know. So 4. Yeah, this one. For this I got 1. Now I will call this. Okay. At this position, if I skip it again, then I will go to f of 5. That will return 0. That will return 0. If I take this one, we go to the next f of 5 with lesser 0. So 0s will be in 1. This will return 0 because again this is n. We will add 1 to it. 1 plus 0. So the answer is 1. So this, for this we got the answer is 1, right? And we were taking the current element, so we add 1 to it. And the answer is 2. The maximum is 2. We will return 2 for this. So for 3, 4, 2 we got the answer is 2. We had only one branch because we were at next 2 and we couldn't take this one because the number of 0 and 1 are more. So this answer because we already is 2 will return 2. We were at this position, so we got 2 for this branch. Now we will follow this branch of 2, 1, 1. Do we have this branch? 2, 1, 1. 2, 1, 1. No, we don't have. Do we have? So let's find this. So I'm at Next.js 2. I have this much zeros and 1s left. I will not take the current one. I will simply go to the next for 3, 1, 1. If I take this one, I cannot take this one because it's more than the one we are allowed. So the answer is this one. Now I will follow this branch. I'm at this position. I'm allowed to look 1011. If I skip this one, I will go to f of 411. If I take this one, I will go to f of 4. The number of zeros will stay the same. The number of ones will increase by 1. So 411, do I have 411? So if I already calculated this part, then obviously I will return the answer from the DP array, right? So we haven't, so we will solve the answer for this branch. I'm at this position. If I skip, so I will go to the f of 5, that will return 0. If I take this one, I will go to the f of 5. I will go to the f of 5, but with 1 lesser 0. So it will be 0 and 1. So this will return 0. I will add 1 to it. The answer is yeah. The answer is 1. For this I got the answer as 1. For this 010. Oh, 10. I will go to 5, this will return 0. If I take this one, again I will I'm at 4. I'm allowed to have 1 1 1 0, and I have 1 0. If I can take this one, for 5 will return 0. The answer is 1 here. This is also 1. We will add 1 to it. The answer for this is 1 0 2. We got the answer as 2 here. We were at index 2. Cannot take this one. The answer is 2. For this got we were at index we were at index 2, right? That ends we were at index 1. So for this part we got the answers 2 1 1. We got the answers 2. We will add 1 here. The another one is 3. Another one is 3. The answer for this part is 3. For this, we got the answer as 3. Right from here. So 3. The answer for this branch is 4. For this answer is maximum, that's 4. And that's for correct. our recursive function. Your position array is the number of n and n is a number. Yep, n is also a number, the number of 0 and 1. Before doing anything else, I have to find 0 and 1 for each element. 0 is 0, 1s are 0, 1 let y is equal to says then str.length plus f str code 0 I is equal to 0. Then I will simply increase the zeros, otherwise it's 1. Then I will return array of zeros and ones. Right. For each string, we are returning an object filled of zeros and ones. Now, if I is equal to n, return 0, or yeah, we don't need to check for the if n is less than 0 because we are not going in that branch in the first place, so that's why only this condition is enough for the base case. Okay. The current element, so we'll go to the next one, I plus 1, else status status. We can take the current in one condition if the number of 0 and 1s exist in this element are less than or equal to the ones we are allowed to have. At this position we are allowed to have m0 and 1s. Now let's get the number of zeros and 1s in the current element. So if m, the number of m's are greater than, or we can write it in a better way, counter the number of counter is the number of zeros and ones for each element. Counter of I dot zeros are greater than or equal to, not greater than, lesser than or equal to, right? Then we can have the current element. The zeros are m and counter of I dot ones greater than equal to the n that we have at this position. Then we can take the current element. So I will add 1 to the answer because we are taking the current element as a part of our subset, so that's why we are adding 1 to the final answer, final length. F of I plus 1, increase the m by this position. We can store this, let I will say zeros of current position is equal to this, and the same thing, zeros of ones. For this I will say ones of current position. So I will remove this, and this will be the same. Okay. Now this position, I will decrease the number of 0 and 1s by this amount. So n will be 1s and n will be decreased by this amount. This will be zeros, this and this will be 1s. And the answer we get from this is answer is equal to this. Answer is equal to answer or this one. Then we will return the answer for this position. We can call this f of 0 index m, and this is our answer. Okay. Yeah, it should be length. They should understand that. And what else? Yeah, this should be correct. Height. Should be let. Correct. So this will cause delay. Let's write dp. N or length. We need map for this. New map. This will be a string and this will be a number. Then let's create one key. Key will be a string, right? String of I. Then this position of m at this position we can have n. So this is our key. If we already processed this key, then we have not.as key, then return not.get key Otherwise, store this one before returning. Given the answer. Not market should be different. Yep, this is correct. We can change this to iterative approach. We can follow the same example. If I'm at this position, right? If I take this one, okay. So what was the previous answer? What was the previous answer? The answer of this position is equal to the maximum of without taking this one and then taking this one. If I take this one, so it will be m minus this part and n minus this, yeah, and I minus 1, right? If I take this one, if I don't take this one, so it will be simply I minus 1 and without changing the number of anything. So I think it's right iterative approach. I will call this the number of zeros and ones. Each element is still one and instead of map, we can use array as well at this position, right? Because we can write the declare as this, because the I can have length from -1 till the end, right? Like that array the length of this will be length plus 1. Now at each position we along with I we need to take the number of the of size 2 and the answer for each one is 0. Makes sense. So because if I'm at this position I need the answer from this position, so what I will ask is give me the answer for I minus 1. If I will consider this, then what was the answer of this position with the previous any name without decreasing the, without adding the any names from this position or zeros and ones from this position. So I think this will work. The 01 will be for Kevin, the ones will be for Ken. This will be an array of like this. We will have the number of N. Yep. Yeah, what is the limit of 100? So, the number of the length of this should be, the length of this node will be 1 into, should be this thing. So I can write like this 101 because the maximum we can have is 100. So I will know it will be correct. We will have at each position I, we will have two array. Each one will have the length from 1 to 101. At each position, this will define the number of, for example, it will be like initially it will be 0, right? If the answer is 2 here, it means at index I, at index 0, the number of the zeros are this ones, 0. So m is equal to 2, 0, 1, 2, let's say 5. So this will be 0, 0, 0. Initially it will be 0, then 9. Using map is very, simpler for this case. 0. Now this H, this will have column. Okay. So the 0.1%. These are the number of zeros, these are the number of ones. Now, how many ones and zeros are possible? Let's say it's 5. So, okay. Yeah, I think it will become, that's not optimal because at the position of M now I have to have, the places for R, N,